yesterday. I can show you what we're doing. And then I'm going to show you something else on the back, and then I'll give you time to finish up those packets from yesterday. Okay? So we're looking at function notation. Please put your phones away. Function notation. So remember, when I see something like this here, this says f of x equals x squared plus 3. That f refers to the name of the function, and the x would be, okay, f is the name of the function, and the x is our input. So then when I see something like number 1, it says f of 3. That means I take 3 and I plug it in for x. So f of 3 becomes 3 squared plus 3. What's 3 squared?
9.
Good. And so then 9 plus 3 would give me 12. Perfect. G of 3. So G of 3 is looking at G of x over here. But it's the same thing. I take that 3 and I plug it in for x. So G of 3 becomes 3 plus 1, which is 3 plus 1, 4. Good. F of negative 2. That means I take negative 2 and I plug it in for x. So f of negative 2 is negative 2 squared plus 3. What's negative 2 squared? Try again.
4.
Negative 2 squared is negative 2 times negative 2, so that's a positive 4. 4 plus 3 would give me 7. Okay, 4, g of 0. I look at my function g, and I plug in 0 for x. So that's just 0 plus 1, which is good. Number 5, f of 2 plus g of 1. So now I have to look at both functions. I plug in 2 for my f function, and I plug in 1 into my g function, and then I just add those together. So f of 2 would be 2 squared plus 3. 2 squared plus 3, that's the f of 2 part. And then I have to add g of 1, so that would be 1 plus 1, right? So f of 2 plus g of 1 is 2 squared plus 3 plus 1 plus 1. What's 2 squared? 4 plus 3 plus 1 plus 1 would give me, 9. 4 plus 3 is 7, plus 1 is 8, plus 1 more is 9. Good. Same kind of thing here. G of negative 1 plus f of 1. So g of negative 1, that means I take negative 1 and plug it in for x. So for the function g, that's just negative 1 plus 1. That's my g function. I plug in negative 1 into the g function, and then I take f of 1, which means I take 1 and plug it into my f function, which would be 1 squared plus 3. So g of negative 1 plus f of positive 1. G of negative 1 is negative 1 plus 1, 0, and then plus 1 squared, What's 1 squared is just 1 times 1, so 1. 1 plus 3, which gives me 4. Good. Okay. This one, F, this is called number 7. Does anyone have any idea what to do for number 7? Perfect. Yes. So for these, this is called a composite function. Composite function. I'm not going to test you on this, but I just like to expose you guys to things you'll see in the future. We start at the inner part, so G of 2. G of 2. So G of 2 means I take 2 and plug it into my G function. My G function is just x plus 1. So if x is 2, it's just 2 plus 1. So what's G of 2 equal? 3. And then I take that 3, and now I need to find f of 3. F of 3. So f of 3, yeah, I take 3 and plug it into my f function, which was 3 squared plus 3. So that gave us 9 plus 3, which is 12. Good. So you start with the inner part and evaluate that, and then you plug that into the other function. So I start with, what do I start with evaluating in number 8? Oops, equals. Thank you. Okay, so for number 8, what do I start with? What do I want to evaluate first? F of 0. F of 0. So I evaluate f of 0, which is, so f of 0 is 0 squared plus 3. F of 0 would be 0 squared plus 3. 0 squared is 0. 0 plus 3 is 3. So now I do G of 3, which is just 3 plus 1. What the heck? G of 3 equals 3 plus 1, which is 4. 4, 12. Okay, what about number 9? What about number 9? Exactly. So y is the input. I put y in place of x. So f of x was x squared plus 3. I just need to replace y for x, so that just becomes y squared plus 3. What is going on? Y squared plus 3. Is this recording? Good, thank you. Okay, what about 10? What's 10 going to be? What am I replacing x with in 10? W. So what does G of W become? Yeah, I don't know why I'm writing W. W plus 1, exactly. Cool? Questions on this? Okay? Okay, so 11, 12, and 13 are for you to do. 11, 12, and 13, that's 3 questions. I'll give you 4 minutes, and then we're going to go over the back. Okay, so you have until 3:35, and we're going to go over the back. 3:36, baby. No, you can have until 3:35. Okay. So I want to show you another nice little thing that function notation can kind of be used for. And we've sort of already done this kind of stuff, but I'm just showing you a different way of writing it out, okay? So this equation here, f of x equals 2x plus 1. What form is this? 2x plus 1, y, think y equals 2x plus 1? Yes, slope intercept. Slope-intercept. What kind of graph does that produce?
Linear.
Hello? He is not. Uh-huh. Yes, this produces a linear graph. Linear graph. And who remembers how to graph something from slope-intercept form?
The B is your starting point. Yeah.
The B is your starting point. So I start at 1. That's my, what is that called? Y-intercept. And then what's my slope? 2, just 2, not 2x, just 2. And what does 2 mean in terms of rise over run? Yes, up 2 over 1. So I go up 2 over 1, up 2 over 1. Then I could go back down the other way, down 2 over 1, down 2 over 1, da-da-da-da. Yay, we graphed a line. There we go. Okay? Don't forget how to do that when you get to Algebra 2. Some of the Algebra 2 teachers get mad at me. But now, I'm going to look at g of x. So we don't need to fill out this table. Don't worry about the table. G of x. What kind of equation is this? It is in standard form, but I also told you not point slope. It has an exponent of 2. No exponentials have x as the exponent. Yes, it is a parabola, but there's another word that we use to describe equations like this. Starts with a Q. Quadratic. This is a quadratic equation in standard form. Quadratic equation in standard form, okay? And have I taught you how to graph anything, graph any quadratics yet? No, I haven't. Next week, I'm going to teach you just the same way that like you can look at this equation and know what the y-intercept is and know what the slope is, and then you can graph it. We're going to do the same thing next week with quadratic functions, okay? But I'm going to show you a different way because sometimes you just forget the rules. Like I forget the rules all the time. And so what we can do is we can use function notation and we can make a table. And that allows us to graph any equation at all. So I'm going to give you a few values. Remember, our x is our input. And I'm going to change this to g of x, not f of x. My g of x would be my output. So I'm going to plug in a value for x and figure out what my input or my output is. Yes.
Did you factor 2 binomials by the x?
Yes, I was going to get there. We'll get there. We'll do that afterward, okay? You can do that, though, if you want to. But we'll talk about that in a minute. So if I plug in 0 for x, that's like saying g of 0. That means I take 0 and plug it in for my x's. So that's 0 squared minus 2 times 0 minus 3. What's 0 squared? And what's 2 times 0? So what's 0 minus 0 minus 3? Negative 3. Perfect. This refers to a point on the graph. When my input is 0, my output is negative 3. 0, negative 3. Not the, yes, it is the y-intercept, exactly, right?
The x-intercept with the binomial. And then what is?
Yes, but I'll explain that in a minute. Let's plug in 1. Let's plug in 1 for x. So g of 1. G of 1. G of 1 would give me 1 squared minus 2 times 1 minus 3. Just plugging in 1 for my x. 1 for my x, right? What's 1 squared? Minus 2 times 1? What's 2 times 1? 2 minus 3. What's 1 minus 2 minus 3? Good, negative 4. again, that is a point on my graph. When my input is 1, my output was -4. 1, -4. Let's do 2. G of 2 would be 2 squared minus 2 times 2 minus 3. What's 2 squared? 4 minus, what's 2 times 2? Yeah, minus 3. So 4 minus 4 gives me 0, and 0 minus 3 is -3. So again, another point on my graph, 2, -3. 2, -3. Let's plug in 3. G of 3. G of 3 is 3 squared minus 2 times 3 minus 3. What's 3 squared? 9 minus, what's 2 times 3? Minus 6 minus 3. What's 9 minus 6 minus 3? 0. So 3, 0 is a point on my graph. When 3 is the input, 0 is the output. And what is that point called, Micah? Yeah. Okay. Now I'm gonna go backwards. I'm gonna put in -1. So G of -1. So -1 squared minus 2 times -1 minus 3. What's -1 squared, Daniel? -1 squared?
1.
Yes. 1 minus, what's 2 times -1? -2 minus 3. So I have a minus, a negative. What do I do with that? Minus a negative. What does that become? Positive. So 1 plus 2 is 3 minus 3 is 0. So what is this point as well? Another x-intercept, isn't it? Right? -1, 0. Okay, so you can see now that we have our parabola. Okay, and if you continue with your math career beyond, especially beyond, into Algebra 2 and beyond, setting up a table is a really nice skill to have. I can't tell you how many tests I avoided failing because I remembered how to do this. I don't always remember the rules because the rules are just kind of annoying and hard to memorize, and I don't feel like memorizing them sometimes, or I forget, or I haven't seen it in years, or whatever. But I can always make a table. I can always make a table and graph from that table. So I'm showing you this because of that, because I think it's just like a really easy thing to remember to do. But also it's important to recognize that an equation can show up like this. I could write it out like that. It can show up as a table, or it can show up as a graph. All three of these things are equivalent information. They're all saying the same thing. They're just displayed differently. Cool? And let's talk about what Micah was talking about, because where are my x-intercepts on this parabola? Where are my x-intercepts? Where does the graph of the parabola cross the x-axis? -1 and 3. So remember what I told you about, like when we're solving something, right? When we had like, I don't know, I wasn't planning on talking about that. But anyway, if my x-intercept was at 3 and at -1, that means that in factored form, this is going to be x minus 3, x plus 1. Right? Because this tells me it's the same number, opposite sign. Same number, opposite sign. Does that kind of make sense? And we'll talk more about that later. But yeah, factored form tells you the x-intercepts really, really quickly. Okay? And then my y-intercept is right here. We know those terms. I want to tell you a couple other vocab terms. Does anybody know what this point is called? There's always this point on the parabola where it kind of turns around. Yeah, what is it called?
Apex.
Not apex, but it does end with ex, not depex. I'll start spelling it backwards. Vertex, good. Vertex. This is my vertex. Is my vertex the minimum or the maximum on this graph? Minimum. But I can also have a parabola that looks like this. In a parabola that looks like this, would the vertex be the minimum or the maximum? The maximum. Good. Okay. And then do you also see how our parabola is like the same on both sides? It's kind of like a mirror image of each other. You see that? Yes? This line here, the middle of my parabola, it goes through my vertex, is like if I were to fold the parabola in half, it would be along that line. Do you guys know what the word is that would describe something that is like the same on both sides? Not parallel.
Congruent?
Not congruent. Symmetrical. Good. This line that goes through the middle of the parabola is the axis of symmetry. So parabolas are symmetrical, which can be very useful information as well. Okay, so I'm going to hand back your packets from yesterday. And this kind of relates to especially the stuff you saw on the back. So I'm just going to explain a few things. These packets were out of 30 points. 30 points. You know where to get the packet, don't you? Wednesday folder. Okay. So if you didn't get a packet back, that means you didn't hand it in. So you have it somewhere, or you'll have to grab it from up here. Okay, so on the back of your packet, there's a couple of questions that sort of related to what we just did. So the number one, you're given a table. Bless you. You're given a table. And it tells you to find f of -2. So that means when -2 is the input, what is the output? So let's do an example similar to that up here with this one. If I said, let's look for f of 2. When 2 is my input, what is my output? -3, right? F of 3 would be what? F of
0
would be 0, right? So it's just looking at, remember, the thing in parentheses is always the input, okay? And then hello. Hey. He did not. Thanks. Bye. And then number 4 on the back page of your packet, we had, it's essentially, I gave you a graph of a parabola like this, and you just need to fill in the table. So I'm going to fill in this table with this graph, right? So when 0 is the input, my output would be -3, right? I just find 0 on my x-axis and find out where is my graph at 0, which is at -3. Where is my graph at +1? I go to +1 on my x-axis and just draw a line down. It's at -4. Does that make sense? Yes, kind of. So f of 2, I look at my graph, f of 2 is, when x is 2, what is my graph at? -3. When x is 3, where is my graph? 0. When x is -1, where is my graph? 0 again. So I'm just looking at my graph and kind of finding the y coordinate of that x coordinate. Okay. Questions? Comments? Concerns? All right. You guys got the rest of class to finish up this packet. And you're going to turn in the packet as well as the Thursday paper. Packet plus Thursday paper. Yep. And just a friendly reminder, if you have any tests or anything to make up, I will be here at Friday school tomorrow afternoon. There is another Friday school next week, and there's tutoring next week. I don't think there will be tutoring the last week of school, so get your stuff done now. And if anybody wants to continue coloring when you're done, I have quite a few more coloring. Yes. And that will take you there. Yeah.
That last equation on the back just be,
No, I just made a mistake on that. And I think I copied the same exact equation, so. Yep, just ignore that. All I'm checking on today's paper is those 3 multiple choice questions on the function notation side.
I don't remember looking at that thing. Oh wait, I do. Yeah, no, I got it. Oh no, I didn't. Got it.
So you just did h of x, 4x, minus 2x. But we wanted to subtract f of x, this so it's minus 2x, so the 2x is good, but then it's minus. Does that make sense? You would just turn that into a negative sign. Does that make sense? No. So it's just, I'm just gonna write it out, okay?
Oh look.
4x minus 2x minus 5. That's 4x minus 2x. It's really simple. Yeah. A lot of people prefer not to do that. And it was the same, yeah. Yeah, so I just wanted you to rewrite this 2 other ways in function notation. So all you have to do is just replace the f with the 3. Inbox is good. Thank you.
I wrote down I don't understand.
So it's kind of going backwards. They're giving you this, and you need to come up with a function notation, okay? So it's going to be, it's going to look like something like this. D of some number equals some number, okay? So the input here is my W. W stands for feet from the river's edge. And my output is the depth of the river in. No, D stays. But this number is the output.
So then that's the
Okay?
Okay.
Does that make sense?
Yeah.
Good.
Thank you.
You're welcome.
I can't.
He's insecure about it. I was talking to him. I was practicing. I was like, I asked him how many times he doesn't, and he literally doesn't answer. He was about to give it to me. He was about to be like, and I was like, then he was like, actually, I don't want you to hear. I was like, but I went through his playlist today. It was like exactly my experience. I just missed it.
Wait, what's his name?
Okay.
It was the same sort of thing. Remember, when you're subtracting, we've got to distribute that minus sign. So the 2x plus 5 stays the same. And then
No. Wait. I'm not happy.
good.
Okay. That's
Correct. So just for your like terms. Yep, good job.
Long day.
I'm so tired. Yeah, I have to be here tomorrow as well. So not the weekend for me quite yet, but soon enough. Cross off another day. You have a 3-day weekend.
No, I
I have a 2-day weekend.
I don't want to.
If anybody's done and wants to color for the last 5 minutes.
I'm sorry.
You can put it in the box.
your minus. That's what brains gonna change his mind too.
Yeah. No, because that would be multiplying. So just rewrite it. 4x minus 2x. And then where are your like terms? There you go. Mm-hmm.
What are you doing?